Math, math homework, science homework. All sorts of fun things to do. Let me get us started on YouTube, and let me get started on TikTok. It's a short, I'm pretty sure. Yeah, I started it. Come on. What? Didn't see it. Silly YouTube. I'm definitely live, dog. One sec. It'll figure it out eventually. Suffering from success, you could say. The only downside is I don't have much to study. I'm a month ahead on all my lectures. Cool. Yeah, I mean, if you're already good with your classes, you could always look forward towards stuff you're doing in the future, or maybe take that time to develop other hobbies / skills. I always tell students to maybe like do that. You know, if you're already good in your classes, like don't just keep beating a dead horse and stuff. All right, this stream is up. Why do I not see it though? Man, sometimes I gotta like manually set this up. Okay, fine. YouTube video ID. There we go. Cool. And I think it'll load. Nice. What's up, chat? Let's see if chat works. There we go. Chat works. And is this working? Yes, cool. Oh, awesome. Okay, I just had to manually add it. Okay. Nice. All right, let's see. Evoli submitted a question at like 10 a.m. I see this. This is cool. Looks like we're going to be doing linear regression at some point. I'm going to wait for her to... I'm going to tag her if she's watching. Evoli. If you're around, we can do yours. Cool. I'll tell her. Otherwise, do some other ones. Odin root, you submitted a parametric equation one. I've been learning some extra skills. I'm doing engineering, but I'm taking some physics modules. Nice. Yeah. If you're bored, dude, there's infinite knowledge you can like learn in the world. Infinite. Especially these days with like Coursera and everything. You can just go get a certificate and so many other things. And I say it's useful to know how to code. You know, that's a useful skill. I know these days everyone wants to vibe code, which is, it works. And like, I definitely vibe code certain things. The whole website we use for being able to submit like screenshots, like this whole thing, I completely vibe coded this with ChatGPT because I didn't want to have to go learn CSS. But it's important that you understand at least how like code works so that you can read code that like AI writes out. What's up, 1K? Okay, a particle moves along a helical trajectory with this parameterization. Okay, this is cool. I love how they do this and then they put it in component form. Like, dog, what? They could have just done this. They could have just done like this. There we go. That would be fine. Parentheses is for points, not for... This is a vector. Okay, whatever. Find the tangent vector r prime at the time t is equal to 4. T is equal to pi over 4. Okay, cool. Tangent vector. I believe that's the gradient, right? Is that the tangent vector? Let me see. I believe this prime of t is like equal to grad r. Is that right? Gold, what medical field I should go into that doesn't take longer than 6 years to complete? They unfortunately all take 6 years to complete. Being a nurse, I think, is only 3. And they need a lot of nurses these days, especially like male nurses. If you are male. I assume you're male, okay, but... yeah, those... Being a nurse is pretty fucking lucrative. 2 of my sisters are nurses, and I don't know, they work like 4 days a week, maybe 3. I mean, they're brutal hours, And you have to be like kind of cool with picking up after people's shit and stuff, but it pays decent and you can go do whatever you want. Otherwise, yeah, if you want to be a medical doctor, way more than 6 years. It's gonna be 4 years just for the med school, probably another 2 to 3 for your residency, and then you might have to do a fellowship or you might have to do a specialty. It ends up being like 10, and then you got to take all these exams. Like my second oldest sister is a pediatrician. She's 32, I think, and is still taking like her boards for her last thing to say that like she can practice medicine. I'm like, what? Nuts. Okay. Yeah, it just takes a while. Yeah, no, nurses get paid bank, dude, especially if you're a travel nurse. Okay. Okay, so yeah, r prime of t, the tangent vector. Oh, I get it. So if this is a position vector, right? We know that velocity is the derivative of position. So, okay, this is just ddt, right? This is just ddt of r of t. And you got to do it by component, I think. What's a travel nurse? Travel nurse is where you're a nurse, but you bounce between different cities like every 6 months to a year. So, yeah, you don't really stay in one place. You have to be cool with like traveling a lot. Here's the interesting thing here. Wait, is this the square root? Sorry, is this square root over the t as well, or is it just over the pi? Yeah, you do get to try. Yeah, not necessarily the world. Travel nurses travel all over the U.S. It maybe a little bit of Canada. How like medical licensing laws work, you can't really can't go over the world. Also, you don't really want to. The U.S. is probably one of the only places in the world where the medical field gets paid like buku dollars. You go to anywhere in Europe, doctors don't make that much money because their healthcare systems are socialized. They're not privatized. So, I mean, there are arguments between, like, you know, is the medicine as good? But also, it's not ridiculously overpriced like it is here in the U.S. I'm going to assume that this square root didn't go over the t, just because it's going to make my life difficult if it is. I don't really want to. I would love for this to just be square root of pi times t. But maybe it is. Oh. Healthcare in Europe is the worst. I mean, it's obviously not the absolute worst, otherwise more people would be dead. But yeah, I agree. It's sometimes there's a long wait list sometimes to get treated. But on the other end of the spectrum, in the US, if you don't have money, you're fucking dead. Like, you just won't get treated at all. Yeah. You think it might increase too fast if it's just a T? I agree. Let's check. Here, let's try to graph this. One second. I'm gonna tell ChatGPT to just give me the equation for this. I just don't want to type it. I'm just lazy at this point. Sorry, all the e-boys that I'm taking away ChatGPT processing from your AI girlfriend. In Canada, we're really short of medical because everyone's going to the USA. Right, yeah, because, again, you don't get paid very much as a Canadian doctor. So people come to the US because we pay a lot more here. But as a result, also, medical insurance is really expensive. Getting anything done medically is really expensive. This is why a lot of people here end up going to Canada to go get the procedure done. Or they go to Mexico. And yeah, you can argue it's not as good of a procedure, but sometimes it's good enough and it's not going to bankrupt you. Our whole medical system's fucked up. And I say that from, like, my family is very much involved in the medical system. My dad's a neurologist. One of my sisters is a pediatric genetic doctor person, and then 2 of my sisters are nurses. Yeah. And they all agree it's like, it's fucked up. Here, let's graph this. Oh, you're wrong? Oh, okay, wait 1 second. Let's look at the helix thing. They come to Canada just to wait, yeah, for an x-ray. Yeah, that or they just pay cash. Oh, it is t. Aha, it isn't square root of t, right? Okay, so there's a typo on this question. Yeah, okay. Yeah, got you. All right, so let's see what this looks like graph-wise. Well, here, I need to like tell it's a vector, I think. What's up, Reki? Wait, how do I tell it to graph this? Right? Oh, you got a... Thank you, Bedsy. Appreciate the rose. Wow. What is that? Is that like a currency thing in TikTok? Plot 3D? Right, but don't I just send it this way? You're the Wolfram expert, Jeff. This doesn't, like, look like anything to me. Half of... Yeah, are all doctors. Yeah, in some way. Bedsy sent me 8 roses. Look at that. Look at all these roses. Okay, this doesn't actually show me shit, dude. What? Plot 3D. Yeah. You know, maybe... Okay, maybe we just need GeoGebra. GeoGebra. Let's go to GeoGebra. Let's go 3D graph. Parametric plot 3D. That's what it is, Jeff? Oh, okay. And then what was this? T equals 0 to pi? 2 pi? Ask ChatGPT how to write it in Wolfram. That is true. Okay, here we go. No, it got it. It got this. It got it. Okay, cool. So that's if the square root isn't also over the t. So let's see what happens if you put it in the t. I think it's also a helix. Yeah, it's also a helix, Jeff. It's just it's a compressed helix. Yeah, this is a parametric equation. Okay. All right, let's just pretend the square root isn't there. Or I think we kind of have to assume it is there. It is a helix where the distance between the loops change. Correct. Exactly. Yeah. Because this is processing in the YZ plane, but it's advancing in the X direction. I say I don't want to do the square root of t because then this is just a messy derivative, but I think we have to. I think they did this on purpose, unfortunately. Okay, fine. So, the derivative of t to the 1/2, that's just going to be, so if we do ddt, t to the 1/2, that's 1/2 t to the minus 1/2. And let's remember, anything to a negative exponent is the same thing as flipping it and putting it on, in this case, on the bottom. And then this becomes 1 over the square root of t, which is ugly, but okay. Okay, so that's going to be... We're going to have 1/2 square root of pi. Oh, square root of pi over t, right? Is that what we have? Yeah, it's all under the same radical. Cool. Derivative of cosine of 5/2t. Derivative of cosine is negative sine, but then this is a chain rule because you have to take the derivative of 2t as well. So this becomes negative 10 sine of 2t. And then this is going to become 10 cosine of 2t. Yeah. This is the equation of a circle. I agree. It kind of comes from polar coordinates, right? So if you have anything in the xy plane that follows the pattern of a circle, right? And let's say that this is out at a radius r, then the x-coordinate can be written as like r cosine theta, and then the y-coordinate can be written as like r sine theta. So this is what we call a parameterization, right? Because now we're parameterizing the path in x and y by a value r, which in this case is going to be the square root of, or sorry, just equal to 5. And then theta kind of measures what angle this is, or like what part of the track it's been running around in. So we have that in the y and the z direction. So the YZ plane has a circle, but then the x direction precesses. And interesting enough, this isn't linear, Jeff, right? So the spacing between the spacing isn't constant, right? Right. I believe this this spring will start to like compress. Yeah. Yeah, exactly. Right. Yeah. So if we wanted to see this in this plot here, like look, for instance, instead of going from 0 to 2 pi, let's go all the way out to, I don't know, like 20 pi. We should see something cool. Yeah. This is fucking rad. I don't know. I think this stuff is cool. No, but yeah, square root of t is yeah, no, square root of t, graph of square root, right? Looks like this. This is like the square root of x, right? And then you can kind of see this, right? Because if you consider the slope, right, like how quickly this thing is changing, that goes as 1/2 1 over the square root of x, right? So as you get further along here, your slope actually decreases. And so now every revolution, the spinning thing doesn't move as far. Yeah, it's pretty cool, right? Yeah, I think it's fucking dope. So yeah, that's why this is a spring that is getting more and more compressed as you get further along. Pretty cool. I love when you can see that like in the math. Like I know this is a circle. Oh, sorry, this is a circle. And then I know that this is something that's like not going as far as it needs to as t increases. Okay, cool. So that's the tangent vector. Nice. Yeah. Oh, but they want it at pi over 4. Okay, that's cool. We can do that. So that's going to be 1/2. And then that's going to be a square root of pi all over pi over 4. Okay, pi's are going to cancel. 4 is going to go up top. Square root of 4 is going to be 2. 2 times 1/2. That's going to get us 1. I kind of like that. Okay, now I'm starting to think we needed the square root there. Pi over 4 times 2 is going to be pi over 2. Sine of pi over 2, remember your unit circle, right? So if we go up to pi over 2 is here. Sine of that is 1. So this becomes just -10. And then cosine of pi over 2 is 0. So this is 0. Exactly, good. Yeah, so it's 1, -10, 0. And that is r prime. So that's the tangent vector. Okay, cool. What is the component of r prime pi over 4 in the direction of 1, 1 minus 2? I believe this is just a dot product, right? Or sorry, was that projection? They're related though, right? Yeah, projection is dot product. I think comp is something different, right? We did this at some point, right? Comp versus proj in vector. It's a dot product times the vector, right? Yeah. Yeah. Where's the equation for it? I just want the equation. Yeah, here we go. This is it. Love me some stack exchange. It is kind of funny how with the invention of AI, these what used to be super awesome databases of knowledge and discussion have kind of like had their traffic just like crash. Nobody goes to Stack Exchange anymore because ChatGPT has already mined Stack Exchange. So it's actually kind of sad because now people are less incentivized to ask on Stack, so less people discuss on Stack, and so human knowledge stops advancing. That's what I think. Okay. So wait. Projection is comp u in the v hat direction, but people on Stack Exchange are mean. Yeah, I guess they can kind of be bullies sometimes. So yeah, it's component of u in the v direction, which is equal to this. Okay. So the component, yeah, projection is the, thank you, Kashar. It says projection is dot product divided by the dot of the vector you want to project in times the vector you want to project on. Yes. Okay. So like in this example, right? If you have two vectors, vector u and vector v, then OQ, right? I think is like the shadow, right? You see how this like casts a shadow on vector v? And then the comp, sorry, is the comp just the magnitude of it? Yeah. And the component is the magnitude of it. Okay, so the projection takes the magnitude and then multiplies it times the unit vector of what you're projecting onto. Yes. Wow, okay, cool. What's up, Zach? Chrissy says, oh wow, I'm a math major, just starting pre-calc. This looks so scary. What awaits me? Oh no. Oh, it's okay. It's not that bad. This is just kind of like some like technical definitions. It's also a big pile of shit, but you know.
That is one big pile of shit.
Shout out to Zach. I just got news from Zach that I'm going to be doing a podcast episode with him, or I'm going to go on his stream, and he's going to interview me about some cool education stuff. I think we said October 9th. I have it in my calendar, though. But I will announce that, and we'll put it on the big calendar for when that's happening. But I'm excited for that, Zach. It's going to be fun. Okay. Okay, so the component of r prime in the direction of u, or let's say v. I'm gonna call this thing. Let's call this. Well, they said u. God damn it! All right. We have to do this. Yeah. Okay. So then this is equal to r prime dot u over the magnitude of u. I see. And then if you multiply it by u and then divide by the magnitude of u, then you get, then you get the projection. Yeah. No, so I think that, yeah, this is the component, right? And then if I wanted to do the projection of u r prime, that equals the component of u times u, I believe. The u vector. But it has to be the u unit vector, right? So it has to be comp u r prime, and then it's u vector over magnitude of u in this case, because this is the unit vector of u. Yeah, cool. All right. I'm glad we got that straight. Yeah, I hate these. They're just confusing sometimes. Are they going to ask for the projection later? No. Okay, they just want the component. So let's just get the component. Okay. So in that case, that's just this. So 1, -10, comma 0, dotted with, what is that? 1, 1, minus 2? Times the divided by the magnitude of 1, 1, minus 2. Magnitude is always just squaring these and then taking the square root of the sum. So it's 1 plus 1 plus 4, which is 6. So square root of 6. So this is the square root of 6. Cool. And then if I dot these, this component's nothing. So we did this time this, which is 1. Negative 10 times 1, which is negative 10. So you get negative 9 over the square root of 6. Okay. Is it allowed to be negative? I guess so, right? Dot products can totally be negative, yeah? The magnitude is always going to be positive, but sure. Okay, cool. All right, I think that's right. Components can be? Okay. Yeah, negative 9 over the square root of 6. This is technically a form that math people get upset at.
No.
They don't like the square roots in the bottom. So you have to do what's called rationalizing the denominator, which is multiply the top and bottom by the same square root. Which is this is the same thing as multiplying by 1. What's up, Lunar? And so this becomes negative 9 square root of 6, and then this just becomes over 6, because square root of 6 is 6. And then now these both have 3 in it, so it's just negative 3 square root of 6 over 2. Nice. Love it. Okay. I love rationalizing, right? Yeah. There's kind of a cool little trick. You know, anytime you have, I don't know, like x over the square root of a, this is always the same thing as x square root of a over a. This is a good trick to learn. So anytime, for instance, you have like 1 over the square root of 5, this is the same thing as square root of 5 over 5. The denominator. How would you rationalize e over the square root of pi? Jeff with the troll questions today. It's a trap. I'm not doing it. E over the square root of pi. Is it not? Is e over the square root of pi not e square root of pi? But I mean, technically that's an equation for the line tangent to the curve r prime. Wait, sorry. Oh, tangent to the line curve r at time t equals pi over 4. I think it's usually this, right? So for part C, if you want a parametric equation, you usually need plus t times, and then this would be right, r prime x comma r prime y comma r prime z. Is that right? There was a Reddit post about this. The denominator still isn't rational. It can't be rational because pi is irrational, or nah? Yeah, exactly. Yeah, it's just because pi is irrational. Unfortunately. Okay. So I just need the point. I just need to know what is r of pi over 4, right? Because that's my initial point. Ray says, holy flipping flip, please go on back to the beginning of Calc 3. I don't know is this Calc 3? I feel like Parametric is, yeah, Parametric is Calc 3, isn't it? Yeah. Oh, you found the Reddit post? 1 second, let me go find that real quick. Is there someone arguing about the square root of pi? Okay, why is it considered improper for radicals to be in the denominator of the fraction? Okay, and there's a comment that's specifically like hilarious here. Okay. When I asked them why, they said they had rationalized the denominator. Did you know, is pi rational? Wow. Dude, this is the ultimate troll. This is how you troll pre-calc teachers. That's hilarious. Professional development. The answer to the question was 1 over the square root of pi. And they all wrote square root of pi over pi. I asked them why, and they said they had to rationalize. Did you know? That's pretty funny. All right, Ray, what are you saying to me? You're saying, I need this. I got an exam on Wednesday, but I thought it was easy and didn't study, but now I'm nervous. Oh, it's okay. You came to the right place. What was the PD comment? Sorry. Did I miss that? One sec. I almost mentioned the normal distribution. That's too funny. Okay. So r of pi over 4 means we're just going to plug pi over 4 into here. So that's going to be equal to square root of pi squared over 4, comma, cosine of pi over 2. Cosine of pi over 2 is 0. Right, so this is 0. And then this is going to be 5, I think. Cool. Ray says, firstly, what are the core differences between the projection and the components of a vector? I don't know the formula to derive. Yeah, so we just did this, actually, Ray. Good question. So we talked about how... So if you have a vector u, for instance, Ray, right? And you have a vector v that's in this direction, okay? The projection to u, and you kind of see what its shadow looks like on top of v. But then you also need it to point in the direction of v. So that's why the projection of u onto v is a vector, and it's this. The component is a scalar, and that's just what the length of this is. Which is just, yeah, the component is just taking, yeah, where is it? Right here, yeah. So the component is taking the dot product and then dividing by the magnitude of v. So you dot this with this, and then you divide by the magnitude of this, and that tells you how much of this is in this direction. But if you want it to point in this direction, then you take the component and you multiply it by the unit vector v. So what that does is that takes your amount of shadow from u in v, and it points it in the direction of v without making it longer, because unit vectors just kind of give you a direction of where things are going. Yeah. Oh, this is a bonus question on a final exam. Argue whether Reddit post was correct. Sometimes arguing on Reddit is like pissing into the ocean. Like, you're not gonna really get much, you know? there's just so much trolling and stuff going on. Okay, cool, Ray. You do have another question? That's awesome. So, Ray, if you have an actual like homework question you want me to go through, there's a really cool way that, because that's what some student did here. Some student sent me a screenshot of their like homework question. I'm going through it for them. You can do so. Just go to like this website we have. It's linked down below. Where do I have it? Yeah, it's the submit actual. Yeah, go to this website. Submit a screenshot. Conjure says, "Can you show how to solve a Gaussian integral?" Sure, I can try. You want to find me one? Find a question. Find me a question of a Gaussian integral. Take a screenshot. Send it here. And then you can also click on all our links if you want to find out where else we stream, or when else we stream, or when else our friends stream. Everything's there. But yeah, I totally can. Okay, so let's see. That's R. This is what I'm going to call R naught, right? This is the initial point. And this is very similar to the equation of a line, right? You always have like an initial point, which is like a y-intercept, and then you have it plus like some sort of like slope times a parameter that you vary to like move the thing in the direction of the slope. In that case, it's t. So this is my, I would say like R naught, and then R prime we know is equal to, we figured it out somewhere. Was it this? Yeah, it was the 1 minus 10, 0. So that's 1 minus 10, 0, and then that's in the t direction. Okay, and then these things are just added to each other. Okay, cool, great. So then R vector, if you want to like combine these two things, is just going to be pi over 2 plus t, comma 0 minus 10t, so we can say minus 10t, and then 5 plus 0t, so that's just 5. Okay, cool. So I think that's all that is for part C, right? I think we're good with that, yeah? Which, yeah, if you wanted to parameterize this, this is just x equals this is y equals this, and this is z equals this. Cool. Acceleration. This is funny because this is all like physics that we're solving here, right? Acceleration is the next derivative. It's the second derivative. It's the derivative of velocity. And since velocity is the derivative of position, it's the second derivative of position. So, I gotta take another derivative of this? Sure. Okay, so this is velocity. This is r prime of t. And then r double prime of t, which is, so this is velocity, which we found out at t was equal to pi over 4. That was equal to, what was that? Negative 1, 10, 0. That's going to be useful for the next question. Negative 1, 10, comma 0. And now if you want to figure out r double prime, you take the derivative of this. So I'm going to pull the square root stuff out. So I have square root of... Here, let me... Yeah. So we have square root of pi over 2. And then it's we're doing ddt of 1 over the square root of pi, which 1 over the square root of pi is the same thing as 1 over pi, 1 over the square root of t. And the square root of t is the same thing as t to the 1/2. And then 1 over t to the 1/2 is the same thing as t to the minus 1/2. And so now the derivative of this is take the thing down and then drop the power by 1. So that's going to be a negative 1/2. And then minus 1/2 dropped by another full 1, which is dropped by 2/2, is going to be t to the negative 3/2. Which, if you want to write this correctly, this is the same thing as the cubed root of 1 over the square root of t. So this is 1 over the square root of t, and then it's like cubed, I guess. Yeah, and then there's another minus 1/2 here, so let's try to like simplify things out here. So that's negative pi over 4. And actually, if I wanted to combine... Oh, well, wait, sorry. No, negative, sorry. Let me combine this. It's negative 1 over 4, and then it's the square root of pi over t to the 3rd. Yeah, I think that's the simplest way to write it. Yeah? Okay. Derivative of this, derivative of sine is cosine. But then you got to pull another 2 out. So that's going to be negative 20 cosine of 2t. And derivative of cosine is negative sine, another 2. So that's going to be negative 20 sine of 2t. Okay. And now we got to plug in at t is equal to pi over 4. We already know pi over 4 times 2 gets you pi over 2. And on the unit circle, pi over 2 sine is equal to 1, cosine is equal to 0. So this goes away. This becomes 1. Kind of easy. And then this, kind of a mess. Negative 1 over 4, square root of pi over pi to the 3rd over 64, comma 0, comma negative 20. So, oh, this is actually kind of cool. This will cancel out with one of these. Nice. Okay, and then the 64 goes on top, but the square root of 64 is 8. And then it's 8 divided by a quarter. Oh, so this is just negative 2 times pi. No, 2 over pi. Sorry, negative 2 over pi. If anyone needs me to, like, go a little slower and explain that, I'm happy to do that. But this is really cool. This turns into this. Nice. And then let's see. This is 0 and this is negative 20. Okay, cool. So we found the acceleration. Done. The last question here was to figure out the speed. So this is another physics concept. So speed is the same thing as velocity, but there's no direction. So we say speed is the same thing as the magnitude of velocity, which is equal to the magnitude of r prime of t. Now go find the jerk. Jerk is the derivative of acceleration. People that don't believe me, I'll show it to you. It's kind of fun. Speed. Oh, wait. It's, velocity, acceleration, jerk. And then there's snap, crackle, pop. Yeah, here we go. Wants to load today. Yes. So in the world of physics, because physics people are all really funny with how they do stuff. Position is r. Derivative of position is velocity. It's not speed. It's speed if it's just the magnitude. The derivative of derivative of velocity is acceleration. Derivative of acceleration is jerk, and then it's snap, crackle, pop as you keep going up. Physics people are they're funny. They're little jokesters. What's the name for that thing where people will name their experiments intentionally with like funny acronyms? Is it called like a backronym or something? Yeah, I'll find the word for it later. Okay, speed is the magnitude of velocity. Yeah, beauty, charm, which they started kind of changing those. They used to be called beauty and charm. Now I think it's called like something else. Coxsucker? I don't know what cocksucker is. What? God damn it. Jeff. You fucking got me, Jeff. Alright, you gotta laugh for that at least. That's pretty good. That's pretty good. That's good. That's good, Jeff. That was good. That was good. That was good. No, I'm talking about how when they name experiments, like for instance, my experiment, for instance, that I did my PhD on was called the Large Axial Plasma Device. So the acronym for that is LAPD, which is like funny because we live in Los Angeles and LAPD is the name of our police department. So physics people will come up with intentional acronyms, but then they'll come up with like things to justify why they picked it. There's a name for it. I swear there is. Okay, but here, let me finish this one. Okay. So we need the magnitude of this. So I need this magnitude. Oh, actually, no. But I already have this. That's this. Oh, the magnitude of this is just the square root of 101, right? I think it's just this. Exactly, Peter. Exactly. Right? Yeah, that's all we gotta do. Yeah, square root of 101. Nice. Okay, cool. So I think we did everything. Good job, Odin Root. Great question.
Nice.
It's a fun one. I reminded myself what projection and component are. Cool. What's up, Meeson? School year started for you guys yet? I know UCLA technically started today. First day of the class for them. I think a lot of the other colleges have already started, but yeah. Okay, what's the name for this thing? I want to figure this out. Wait, what is it called? Okay, I'm gonna ask chat. Nope. We can use the instance. I can be like, what's that thing where scientists choose acronyms for their experiments that are funny? It is called a backronym. Okay, cool. Yeah, backronym. Yeah, here we go. So, for instance, yeah, like Atlas at CERN is like named after a toroidal LHC apparatus. And then they capitalize the S here, I guess. But Atlas like sounds cool. Bob, big orange ball. Dart, Lucy, Osiris. Sometimes it's done for humor, sometimes it's memorability. Babar, this is fun. This is like a kid's book. Does anyone remember Babar the elephant? Well, that's fun. B factory detector. Meeson says class started 5 weeks ago. Wow, you're in it there. That's in the thick of it. Here, I wanted to like come up with like, there are some funny ones. We have lost 2 little elephants. Here we go. Inadequate, incredible natural abundance, double quantum transfer experiment. Yeah, because calling your method inadequate is bold. That's kind of fun. Gandalf, gas and absorption line fitting algorithm. Yeah. Oh, yeah, for sure. Yeah, Peter. Was the initial function a helix? It was. Yeah, very smart. So, this was the initial function here, Peter. And so we recognize anytime you have like r cosine theta, r sine theta, that's got to be a circle in the YZ plane. And then this is how it processes, which we went to Wolfram actually, and we made a 3D graph of it. In the Thick of It is crazy. What is that 1K? Is that like a movie? In the Thick of It, 2024? Hey, could you help me with throw up physics? Yeah, what is throw up physics? Like vomit physics? Or like throwing a ball up in the air? Physics. Look up the Thick of It. Am I going to regret this? Oh, Thick of It is a KSI track. Oh. With Trippy Red. That's kind of cool. What's it about? I can totally help you on geometry. And Maria and Drovel says kinematics. Yeah, that's totally cool. All right, let's do it. Let's do it real quick. I'll do one for you right here. Which, I have done these. It's the most memed out song of 2024. Oh, wow, that's cool. So, one sec. I'm going to show you real quick, like, where this video is on my TikTok, because you're coming to me from TikTok. I will do it anyways, but just for some other information. All these notifications. Where did I do it? Where did I do it? Not vertical asymptotes. What was it? Yeah, here we go. How to solve 1D projectile motion in physics.
Here's how to solve a 1D projectile motion.
Okay, so this video literally, this one right here, will show you how to do it. This is like a ball is launched up straight from the ground. So here, let me just like take this question. Sorry, I don't use TikTok. It's also on YouTube. I'm streaming on all 3 platforms right now. So we're on TikTok, Discord, Twitch, and YouTube. But if you're finding from YouTube, that's cool. So here, I'm gonna send this to you. Dr. G Moggs. Is it Moggs when like you like talk down to somebody else? Isn't that what mogging is? But here, I'm gonna send this to you anyways. There's a link. That's the video. But let's do it. Let's do this question, and then I'll teach you something along the way, right? Hey man, what's your take on wave function collapse interpretation? Oh, I mean that's a cool thing. I mean that's how reality works, right? Is that wave functions collapse on things? Whenever you're done with the important questions, could I help you with a question? I was helping one. Yeah, for sure, dude. Did you send me the screenshot? James Joyce fan sent me this. That's cool. That looks like a complex integral. Is that complex analysis? And then, okay, cool. Yeah, let's just do this. Here, I will do this question for you right now. Thank you, Maria, for posting this. It's an integral application. Cool. Are you a many worlds guy or a pilot wave? Oh, that seems kind of advanced. Is that like some sort of like theory of existence of the universe? Many worlds. I've heard that before. Is that like multiple dimensions or I forget what that one is. Sorry. And let me catch up with chat real quick. Okay, cool. And then here, Jackson, here's your question. I'll add it to the queue. Just stick around, Jackson. I will do this one. If you stick around, I'll do it. Cool. Okay. I got it. If this is the question, I got it for you, Jackson. That cool? Oh, those are some common things. I'd have to read up on it more. I did plasma physics for my PhD, so I enjoy talking about like quantum effects and stuff, but I don't have as rich of a background in it. Okay, a ball is hit straight up into the air with a speed of about 25 meters per second. How high does it go? Cool. So we're talking about things, Maria, just going straight up and down. Like we don't care about left, right. We don't care about anything else, just up and down. So that tells me right away this is a one-dimensional kinematics question. Am I lagging on Twitch? I don't think so. We are dropping a little bit of network frames. You're right. Fuck. I don't know. Okay. Yeah, there's a little bit of lag. Just lots of lag. Fuck. So, that tells me that my initial velocity... Oh, yeah, we're streaming on everything. Okay, cool. Awesome. This is what I get for streaming on so many things at once. One sec. There you go. I don't know why it's lagging so much. Acceleration. Yeah, acceleration in this case, if something's in the equal to negative 9.8 meters, it's down. Because velocity is, Maria. So if the velocity is changing to go down, then that acceleration needs to be negative. Kind of a simple way to explain it. Up is positive and down is negative. In this case, yes. I've noticed lag too. Yeah, no, I am lagging. I'm gonna wait for it to sort itself out. It usually does. I can start cutting channels, but I don't want to do that just yet. I'm gonna let it try to figure it out. It usually does. Okay. How high does it go? So, Maria, when something is being thrown up into the air, right? Can we agree that the ball is going to go up, it's going to reach some maximum height, and then it's going to go down? Yeah? Cool. Okay. This is like max height. There's something special about the maximum height. Do you know what's special about maybe the velocity of an object once it reaches its maximum height? Let's think about like what the that's okay. Let's think about the velocity here, right? The velocity here is big, right? Because this thing's moving up, right? Here we would say like velocity is like very positive, right? And then as it goes up, right? As the ball moves upwards, it starts to kind of slow down, right? You ever notice when you throw something up in the air, right? It's really fast at the beginning and then it starts to slow down. Eventually, when it reaches its maximum height, here, the velocity is equal to 0. It slows down going up, exactly. And so eventually, it hits a maximum height, and then it'll start to fall. Exactly, yeah, good, okay, yeah. So yeah, at maximum height, yeah, VF is equal to 0. Good, okay. All right, cool. VF equals 0, and they're asking how high did it go, all right? So, this is where I like, there's just kinematics equations that you need to work through, right? Kinematics equations. Where's my favorite diagram for them? This one. I like this one. Yeah. Physics seems so fun compared to chemistry. I can try that silly guy's question. It's a fun one. I like chem too. Chem's great. So do you know these equations, Maria? Okay, cool. So what you want to do in physics for this types of stuff, sweet, yes. Yeah, I see it, Jackson. It's the one with the purple page. You submitted it like 6 times, but it's okay. Yes, the third equation. Yeah, exactly. You want to use the third one. Because you have a final velocity, you have an initial velocity, you have an acceleration, and the only thing that's missing is the distance it travels. Yeah. Oh, it's okay. Maybe the thing fucked up, Jackson, but I see it. It came in. I see it. You're good. So let's use this one, right? So I'm going to say 0 squared is equal to 25 squared, right? Plus 2 times A. A in this case is negative 9.8. Very important for it to be negative, okay? And then this is going to be the change in X. Really, things are moving up and down, so I'm going to say this is just the change in Y. It doesn't matter like which one you say, as long as it's the direction. At first, I thought the website was a scam. Aw. What would be a better way for you to know that it's not a scam? I'm always curious for like feedback, Jackson. Like, what would cause you to trust it more and be like, this isn't sus? Maybe it looked better. I know it's like kind of basic, but because yeah, I use ChatGPT to just vibe code that thing, honestly. All right, so let's pull out the calculator. And so, oh, I see. Yeah. I need to get the SSH, the SSL fixed on it. Yeah, I'll do that. Yeah. I gotta update the SSL certificate on it. Okay, minus 19.6 delta y, right? So now you can solve for delta y. So you just move this over. Equals 625, and then divide by 19.6. Divide by 19.6. I will trust you for now. I don't know exactly what Math 30-1 is, but I probably can. Do you know what the common name for that class is? Guilty Scarab? Yeah, it's the same calculator you use in high school, right? Yeah. Yeah, it's a TID4. I like to show people how you do things on this calculator. So that you can, like, repeat it in your class. So cool. So this is it. See how that's the maximum height it's going to reach, Maria? Yeah? 31.9? Cool. Okay. Now it says how long is it in the air? Okay. So how long it's in the air, right? This is actually kind of cool. There's two ways to do this. So we can figure out how long it takes for it to go up and then just multiply that time by 2. Because as long as something starts and ends at the same position, right, when this falls, then the time it takes to go up is half the amount of total time it takes to, like, eventually get back to down to the ground. But that won't always be the case. Sometimes you'll have stuff that's, like, starting here, and then it's hitting the ground. Now the starting position and the ending position aren't the same. So you gotta be careful. Oh, nice. That's their course? It's a weird Canadian thing? We have lots of fun, weird Canadian friends. But yeah, I probably can help with it. So, we want to do something with time, okay? So one way to do that, right, would be to do this equation. Right? We could do this one. Okay, then you do this one. If it starts in the middle there, do this, okay? Because now what you want to do is you want to say the change in position, right? So if something at its initial position is equal to 0, and then its final position is equal to 0, then the change in position, which is equal to x final minus initial, that's also equal to 0. Okay? Because we're going to talk about things starts on the ground and eventually ends on the ground. Okay, so I have 0, right? And actually, sorry, I don't want to use this one. This is a bad one. Sorry, I want to use this one. Yeah, use this. Use this one. Sorry. So change in position is 0. V initial, we know, is equal to 25. And then the acceleration is equal to negative 9.8. So then I say 0 is equal to 25t minus 1/2. Yeah. The last one's kind of silly. T squared, okay? So now we just have to solve this for t. So move it over, right? So this is minus, which is... Let me think about this, sorry. I need it eventually to be plus, though. Oh, sorry, it's plus 1/2 times negative 9.8. Then that becomes minus, and then you throw it over. Yeah, okay, got it. So this becomes 4.9t squared is equal to 25t. Yeah, thanks, Jeff. Yeah. So what I'm going to do here is... Yes, this is quadratic. This is quadratic form. I mean, quadratic form is technically this. It's technically 4.9t squared minus 25t plus 0 is equal to 0. This is technically standard quadratic form. Standard quadratic form is ax squared plus bx plus c is equal to 0. The reason being is because this has two solutions. But t is like x. Yeah. Okay, you can put it in this form, because then this is actually kind of nice. Do you see how there's a t squared here and a t in here? That means I can factor out a t. Of course, Jackson. Yeah, I'm gonna help you. Don't worry. So this is t times 4.9t. If I pull a t out of this, minus 25. And then this is equal to 0. This is like factoring, is what it is. You could use the quadratic equation, but it's kind of overkill. Is there an easier way to get it? I get so lost with the quadratic form, with the quadratic formula. You want to get good at doing this, though, Maria. Like, because this will come up a lot. Yeah. Yeah. We're not going to do the quadratic equation. We're going to factor. We're going to pull a t out of everything. So that now that we just have this, okay? And this is pretty cool here. Watch. In order for something times something to equal 0, either this can equal 0 or this part can equal 0. Right? Because if you had 0 times this, that's going to be 0. Right? This just all goes away. If this whole thing is 0, I don't care what this is. That times 0 will also be 0. So this tells you right away you have two solutions, right? T equals 0 is one solution. The other solution is to do 4.9t minus 25 is equal to 0. Which you can move the 25 over. So you get 4.9t is equal to 25. Divide by 4.9. Divide by 4.9. Yeah, sure. Yeah, I am streaming on Twitch. So Jackson, that same website that you went to, wherever it was, there was a link there. Yeah, there's a link here that says watch live on Twitch. Just click on that. It'll take you to my Twitch. Good. Yeah, t is equal to 5.1 seconds. Yeah. Good. Okay. Good. Does that make more sense, Maria? Oh, math. Well, this is technically physics, but yeah. Math is physics. Okay, thank you. I'm just going to pray I pass my test. I think you're going to go do good. What's up, lads? You're going to do well, Maria. Yeah. Just go through the practice questions. The nice thing is your teacher gave you the answers on these things. So you can try doing this yourself and see if you get the right answer. Yeah, you're very welcome. Okay, good. All right, good luck on your tests. If you have any other questions, again, you know where to find us. We stream 4 times a week now. So Sunday, Monday, Tuesday, Wednesday. So come on by. We'll help you out. What's the topic of the day? I'm just answering whatever questions. Let me help out Meezan real quick. Meezan asked first, and then Jackson. I'm going to do yours. And then Guilty Scarab. I do see your question as well. I see this one. This is a good one. Domain and range. This is great. Yeah, we'll do this later. Just hang tight. I will do them. Let me see. Meezan says only question 25. Oh, the frustum of a cone. Great. Love these. I think this one you have to do like arc length. I can already tell what's going to happen here. And then where's question 25? What's it asking for? Oh, okay. Sorry. Yeah, I see it. Anything, honestly. I do anything math or science from middle school to like upper college. So, I mean, today we've done some physics. We've done some vector calculus. Yeah, we do a lot of stuff. All right, wait, why can't I move this over? Yeah. Okay, cool. Yeah, a student came to me during drop-in while I was tutoring and I was confused. That's totally cool. Yeah, no, let's do it. Let's rack this one out. This is a good question because this is physics and math. It's kind of like a combination of two, which is cool. One sec. I need to figure out where my chat is. There's my chat. Okay. Okay. So let's think about what work is, right? Work required to pump water out of a spout. Here the spout's at the top, right? Jack's King Cole. Not yet. Don't worry. So let's think about work, right? So work in the definition of physics, right, is equal to the integral of f dx. Okay, which is the force you push on something integrated over the dx, or the distance that you push it. So if the force is changing as a function of position, you need to leave this in like integral form. However, the force of gravity, luckily, is independent of height, right? So the force of gravity here, that's just going to be equal to m times g, and then dx is going to be the height of this water that I like, how high I need to like bring it up. Okay, so we could call this. I am gonna call this d. I'm gonna say mgd. Okay. Now, the issue here is that as you start pumping water out of this cone, the distance you have to pump it out changes, and also the mass of that cross section changes, right? Oh, this is you. Okay, cool. Nice. Cool, Jax. Yeah. We're gonna do yours next, Jax. Yours is the one with the purple paper, right? I'll do yours next. So, okay. So if I want to do like dw, right? That's gonna be equal to dm. I'm gonna call this like dm times g times d, right? And we need to come up with an expression for what dm is. What's up, Ethan? So dm is like, you're good? Nice, dude.
How are you doing?
I'm good. I'm doing a physics question. It's kind of a physics math question right now.
Calculus? Or?
It is a little bit calculus based. I gotta think how this works. Oh, I wonder if I can just do a bunch of disks. I'm sometimes not allowed to do a bunch of disks because this is diagonal, and like you need an arc length sometimes, which is fucking annoying. Can I do a disk? I want to do a disk. Okay. So in this case, dm is going to be equal to, mass is equal to rho v. So it's equal to the density times the... Is he the guy from your desk? No, he's not from my basement. The density is given to us. It's 62.5 pound... Dude, what? Pound feet? Dude, what? This is fucking gross, dude. What? God damn it. Pound feet? Okay. I think G is equal to 32. Is that pound... I don't know. Pound feet per second or something? I don't know, actually. I really don't know what it is. I think it's like feet pound per second squared. Is that what it is? Okay. I think G is going to be 32. I didn't choose it, man. Yeah, well, it's just fucking gross that they're using feet and stuff or whatever. Okay. Okay, so mass is equal to M, which is M, is equal to the density, right? This is density times the volume, right? Density times volume is your total mass. We learned that in like 5th grade. So, that's going to be equal to is equal to rho, and then the volume, it is 32 foot-pounds per second squared. Okay, thank you. Okay. Sorry, it's pound-feet per second squared. Okay, great. This is G, which is the same thing as kind of like the 9.8 meters per second squared. But, like, I think per kilogram, maybe. Yeah, whatever. It's just, it's that conversion. So, the volume. The volume is going to be a circle, right? So this is going to be pi r squared, and then it's going to be times some like height, which I'm going to call, let me call this dy. Is that cool? Let's call that like dy. Okay. So this is going to be rho, and then this is going to be pi r squared dy. Yeah. Yeah, I know, right? It's hurting me, dude, the units. Okay. And so that's dm. So dm is equal to rho pi r squared dy. Cool. So we have rho pi r squared dy. G, and then we got to define the distance. So I'm going to call this... I'm going to call this y is equal to 0. So then the distance something has to travel is going to be 8 minus y, right? So now this is dw. Yeah? We good so far? I can see it later. Let me just see if I get the right answer. If I get the right answer, then I'm cool. Everyone should use SI units. Okay. Here's the issue, though, okay, is that R depends also on Y. Right? So the radius of this, like, disk sliver as I go up is increasing as the height goes up. So this is where you have to draw... fuck. It's like a... You gotta, is it a triangle? Am I doing a triangle? I know this is 3. This is 8. And then it should eventually do... Someone's saying cylindrical coordinates? What? Really? I don't think I want to do cylindrical coordinates. Sorry, let me move this. This to be nicer. Maybe I could do cylindrical coordinates. Yeah, because you're right, because it does include Z. But I still need to know... But this isn't a cylinder, first of all. It's a cone. Right? If it was a cylinder, it'd be great, but it's a cone. And a cone in 3 dimensions kind of, like, defaults down to... I say it flattens down to a triangle in 2 dimensions. So I just need an expression for what this is. Like, what is R in terms of, like, this? Yeah, maybe. Yeah. I think maybe if I had the equation for the cone. Man. I need to relate R. Why can't I know? I want to know this. If I know this, I'm great. Then it's just like this over this, and then it's just like, yeah, whatever, like this over this. Yeah, it's like this to this, and then it's this to this. Oh. Yes, I agree, similar triangles, but I don't know the length of this whole thing, right? Just use trig? Can I? How can I use trig? Oh, you guys are right. You boys are right, sorry. Because, okay, take a nap, Jax. Just, this will be over soon, don't worry. This is also 3, right? Because if this is 3 and this is 6, then this is... It's not drawn to scale, right? This is 3, this is 8. Yeah? Okay. I think this is actually kind of cool. This is actually really cool. So, yeah, fuck. Oh, this is actually really dope. So this is now my similar triangle. Okay. Because now, this is Y, right? So let's call this thing here like r prime. Okay. So now I know that 8 over 3, right? This to this is the same thing as y to r prime, right? Do you see that, Mizan? Do you see how, like, this is my one triangle and this is my other triangle? So that tells me that r prime is equal to 3/8 y. And then r, which is the total radius, is equal to 3 plus r prime. Right? Because this distance is 3, and then this is r prime. What's up, Master Chief? So this is equal to 3 plus 3/8 y. Oh, very cool. I think that's right. Okay. Cool. I was hoping it was ear rape, yeah. I'll get to yours guilty. Just give me a second. Aren't our slices horizontal? Yes, so our slices are this way. I agree. Right? But in order to get the area of this slice, I need to know the radius, right? Because that's what we had here for the volume of my slice was pi r squared, right? That gets me this times dy, which is the height of that slice. So I need to know how the radius of this slice varies as we go further and further up the cone. Right? Do you see how, like, this radius will be bigger? So this is a function of y. And what we did here is I kind of took like a two-dimensional cross section of what the cone looks like, so that now I have a relationship for what r is as a function of y. I know r is equal to 3 plus 3/8 y. And if you want to check if that's correct, right, you can check the boundary conditions, right? When y equals 0, the radius is 3. That makes sense. And then when y is equal to 8, so when we're up here, the radius should be 6. And it is. So this is correct. Okay. Let me just get through it real quick. And then if I'm correct, I'm correct. If I'm not, then fuck it. All right, so dw is equal to... So we have rho. And rho is 62.5. So 62.5 pi... Or, yeah. Rho is 62.5. Then you got pi. Then you got g, which is 32. So this is gone. This is gone. This is gone. And then it's the integral from 0 to 8. Because that's the amount of water I'm pulling from y equals 0 to y equals 8. Yeah, it is excellent, right? It's pretty cool. And then this is going to be r squared. So this fucking nightmare. So sorry. This is 3 plus 3 over 8y squared times 8 minus y dy. Okay. Which Dr. Mog. Yeah, I'm getting mogged right now, dude. This sucks. 62.5 times 32 times pi times integral from 0 to 8. And then this is going to be 9 plus 9 over 64 y squared plus 18 over 8y. But then this is all also times 8 minus y dy. Okay. We're getting there. Yeah. At this point, the integral just really just blows dick. Honestly, this sucks. All right, fine. 72 plus 9 over 8 y squared plus 18y minus 9y. Is that so, Elmo? 9 over 64 y cubed minus 18 over 8 y squared dy. And then you just integrate this. So all this again. And then this is going to be 72y, and it's from 0 to 8, right? So this is cool. So I can get rid of the 0. So this is 72 times 8 plus 9 over 8. But integrating this goes up by 1, divide by 1. So this is 2 times 8, 8 cubed, plus 9 times 8 squared, minus, oh, yeah, minus 9 halves times 8 squared. I should have combined like terms here. Minus 9 over 256, 8 to the 4th. Minus 18 over 24, 8 to the 3rd. Here, I think it's a 2. Wait, which one? Which denominator? Oh, the first y squared term I integrated. Oh, thank you. Yes, thank you. Thank you. Cool. All right. Cool. Elmo says he wants to know the last 4 numbers of my mom's credit card number.
Surprise, motherfucker.
No, not today, dude. Okay. Okay. This is 9 halves times 64. 9 minus 18. So that's minus 9 over 24. 8 cubed. Plus 72 times 8. And then minus 9 over 256. Times 8 to the 4th. What's up, Evoli? I saw your question. We'll do yours soon. Just, I got a little bit of a line now. Sorry. Three, 4, and 62.5 times 32 times pi. Okay, cool, awesome. Yeah, what the fuck is this number? This is a pain in the ass, dude. Okay, 62.5 times 32 times pi. This already seems like way too high, but maybe. 9 halves times 64 minus 9 over 24 times 8 to the 3rd. Okay, cool, maybe. Plus 72 times 8 minus 9 times 8 to the 4th over 256. And if I made no calculator errors, that gets me that, which divided by pi, I don't think it's going to give me the right answer. They got 33,000 pi. I got really big number. Oh, man. Ugh. I feel like what I did was okay, though. All right. When in doubt, ChatGPT'd out. I want to see like where it... I'm gonna use ChatGPT just to see where I went wrong. It's probably just a calculator error somewhere. A sec. It will find it. Yeah, sure. Yeah, you can send me the solution from the book. That's cool. I'll go through it. Get rid of the calculator. It's just a calculator error. It's always just a calculator error, right? Let me see how they set up the integral. I'm curious. Computing the work to pump water from a frustrum. Did it in 18 seconds. Oh, you know where I fucked up? No. What? I think they fucked up. Sorry. No. The radius is 6 at the top, not the diameter. Okay, let me see what they got. Okay, we had up to here, right? So let's see what they did. Okay, cool. Okay, so we were good with... wait, 16? R is equal to 3/8 16 minus x. Oh. They're calling this x equals 0. That's why. So I think I had just 3/8 x. Right? Yeah, 3/8, and then I added 3. Yeah, okay, cool. Yeah, okay. So this is fine. So, yeah, 62.5. They go from 0 to 8 as well. I went from bottom up. They went from top down. But okay, 62.5. So instead of x here, I have 8 minus x, which is okay. And then instead of 3/8 16 minus x squared, I have 3 plus 3 over 8 squared. Yeah, okay. Yeah, my error, and what did they get? Sorry, what did they finally get? 33,000 pi. Oh, wait a minute. Yeah, 1.04 times 10 to the 5th. What did I get? I got 1.04 times 10 to the 6, and then with another pi on it is what I got. Okay. We have the same methodology. I think there's probably just some calculator error in here that I don't really need to, like, mess around with. But we did it the same way. They started at the top. But notice how they did the same thing here, right? They did this. We also did that. So, it should work out. Wait, also, they don't have any 32s in here. Oh. Wait, yeah, where's their G term here? Sorry, what? Oh, sorry. You don't... Yeah, okay. No. Yeah, I'm going to do your question right now. No. I know exactly what the error here is. So, sorry, this is the issue about working with fucking feet and shit instead of just meters per second. You don't need the G here. Okay? You don't need the G. Yeah, Jeff, you misled me. Okay, so you don't need the 32. The 32 goes away. Because this is the force. Yeah, we included it in the weight. Yes. Okay, cool. So, now that means, going back to my answer here, which was this, I'm going to take this and I'm going to divide it by 32. Yeah, the mass versus weight thing, it's fucking confusing, dude. Okay, we divide this by 32. Okay, beautiful. And now I'm going to divide that by pi. There, and there we go. I get 3,300 pi. Wow. There we go. Dub. I knew I was fucking close, dude. I was like, what? Can I see the whole thing and take a screenshot? Yeah, sure. Okay, this goes away, this goes away, this goes away. Yeah. Okay, sorry, enough of that, sorry. Yes, I will stream as long as I need to tonight. Don't worry. I'm going to do... Ethan, let me do Jackson's question real quick, because he's about to go to bed, and then I'll talk with you, and then I can do whatever other people's questions. I do want to talk to you, because I haven't talked to you since you got your prize, but... I'm
still going to be active.
Good, awesome. I'm glad you're going to still be active. Okay. Cool, a 24-hour stream. Gotta get those fucking watch hours up, dog. Okay, sorry. That was a cool, very, very cool question. We got the right answer. I'm super happy. It's just... this... No. No trouble, dude. I really enjoyed that question. I thought that was really fun. Okay, I'm gonna do... let me pull Jackson's in, and then Scarab, I saw yours as well, and then Evoli, I saw yours as well. I'll tag her, maybe if she comes back. Sorry, let me find the screenshot that got sent. Thank you, everyone who's submitting these. I can understand these. Okay. Which question do you want? I'd see two of these, Jackson. It is time for your question right now. Billy's like, I'm still here just vibing. Yes, good. You want me to do all of them? Okay, well, I don't know if I can do all of them. That's a lot of time. But I'll try to do as many as I can. Is that cool? Are these them, Jackson? 1, 2, 3, 4? Did I hear 24-hour stream? Maybe. They're all due on Friday. Well, here. How about I help you do... If I help you do one of them, or I'll help you do two of them, Jackson, and from that, you should be able to do the other two, because the key thing here is not to, like, do your homework for you. It's to show you how to do your homework so that you can do the other ones. Is that cool? So, let's look at this real quick. So, it says, what is the equation of a line parallel to y equals 4/5 x plus 2? Okay. So, line parallel to y is equal to 4/5 x plus 2 and passes through 1, 2. All right? All right, cool. And what equation, what form do they want it in? Okay, y equals mx plus b. All right, cool. So, Jackson, the equation of a line, that's y is equal to mx plus b, right? Does that make sense? Yeah? And what I need to do is I need to figure out the slope and I need to figure out the intercept. Okay. Yeah, no, Peter, for sure, yeah. And that's why integrals are really cool, because when things are, like, functions in themselves, you can, like, account for it. It's super cool. Yeah, like the DM term, for sure. So, slope. Here's what we say. The slope of lines that are parallel have the same slope, okay? So this is what we're going to say. Same if lines are parallel. Okay? So if you have lines that are parallel, they have the same slope. So now I know that the equation of my line must be equal to y equals 4/5 x plus b. Good so far? Exactly, AC. Yes, parallel lines must never meet, and thus for that to happen, they have to have the same slope. Yep. So, in any of these other questions, when they say, like, equation of the line parallel, equation of the line parallel, Jackson, these are going to be the slopes for your new line, because they have to be the same slope as the line they are parallel to. I have to go to... But we're almost done, dude, Jackson. This is like 2 seconds. Watch. Same slope. And then to figure out B, you need to just plug in a point. Okay? In this case, you plug in this point into here. And so the y for that coordinate is 2. So I'm going to say 2 is equal to 4/5. And then now my x is equal to 1. And then plus b. And now you solve for b. Okay? So, you can do it, Jackson. So, 10/5 minus 4/5 is equal to b. So that means that b is equal to 6/5. Okay? And now you're done, right? Because all you have to say is that y is equal to 4/5 x plus 6/5. And that's it.
Good job.
Do you see that, Jackson? Yeah, it is. Yeah, the word question, yeah. Good job teaching people without asking a penny. Thanks, Phi. Appreciate that. Yeah, well, this is all part of a nonprofit. So we have like a big nonprofit called Actual Education, and what we do is we teach students for free, we run tournaments, we give out prizes, we incentivize people to do good things in math and science. I'm a blessing. Oh, thank you. I like that. Give me some booms, dude. Big stretch. Jackson isn't vibing on the do it on your own vibe. I've been there, yeah. Yes, Bree. And if you're looking for the perpendicular line, it's just, well, it's the negative reciprocal is what I say. It's a little bit more than the inverse. So perpendicular lines, this would end up being -5/4. What's my formal education? I have a PhD in physics, and I don't know, I've been tutoring for 15 years. I taught 2 courses at UCLA the last quarter for undergrad physics. So, but I've been teaching everything math and science for like probably 15 years at this point. Like chemistry, stats. We're going to do some stats here in a second. Anyways, it's the negative inverse. Exactly. Yes. You were so close. Good. Okay, cool. All right. Well, Jackson went to bed, but good job, Jackson. I'm glad I could teach you for the 40 seconds before you wanted to go to sleep. Okay. Let me catch up on my chat real quick. Ethan, what's up? You want to say some stuff? And then I'm going to do Guilty Scarab. I have questions. Don't worry. So I see this one that got submitted. I see yours, Guilty. And Evoli, I have not forgotten about yours as well. I see yours as well. Nice. 2nd year in theoretical physics. That's sick, dude. 2nd year grad school? What field? What school? I did plasma physics at UCLA. That was my PhD. Oh, this is the adult version of meeting your hero? Aw. I don't think I should be a role model for all things, but maybe for the education stuff. Yeah, I'll take that. All right. What's up, Ethan? How's life? What's crack-a-lackin'? Your mic's not working, by the way, Ethan. It was working for a second. Okay. While Ethan gets his mic to work. Scarab. Yeah. I can, yeah, one space, mean like 1D physics? Yeah, for sure. Yeah, I just did a 1D physics question here. This was us doing 1D physics. Yeah, if you have any questions, you want them to get added to the queue that I go through, there's a website right here. Just go down, click the link, www.actualdiscord.com/submit. I know it says it's like not secure. It's because I haven't finished getting the SSL certificate to work. I coded that whole thing myself. Well, really ChatGPT did. I vibe coded it. But I need to figure out how to get my Debian server to accept SSL certificates. It worked at some point, but I don't know, it got reset. I also like don't want to reinstall. It's like it's a super old deprecated version of Linux. I think it's like Debian 14 or something, and they're up to like 19 now. Cool, King's College. Nice. I had a really good friend that went to Imperial. My dad went to Cambridge, but he didn't do physics. He did genetics or something. I don't know. Are you a Linux user? Yeah, I've used everything. I mean, we're on Windows right now, but yeah, I have a Mac laptop. I have a Windows gaming rig. I think if you ever type in, is this the command setup? Here you go. This is the most recent photo of my setup. If you want to see like how many goddamn monitors I have here. So 1, 2, 3, 4, 5, and there's a couple more virtual ones, but yeah, this is all running on a Windows setup. There's no way I could run this many screens with OBS and all the plugins on Windows. But then yeah, I have a Mac laptop, and then all my servers are Linux. So never enough screens. Yeah. Okay. Let's see, Scarab. The graph of y equals g of x is the image of the graph y equals f of x after a completion of transformations done below. Identify an equation. Oh, that's sick. Maxwell did. Oh, that's super cool.
Okay, sorry about that. Yeah,
that's okay.
Life is alright.
Life is alright. Oh, that's great. Life is great.
But yeah, I like to say stuff. So since I'm in college, of course, I'm taking classes. I'm trying to see if I could aim for like a 4.0 GPA.
Nice. Yeah, go for it, dude, for sure. Go get a 4.0. There's nothing stopping you from a 4.0.
And all I need to do is just get 90s in all my classes. However, there are some setbacks. There are some setbacks.
Okay. Setbacks happen in life. It's totally okay.
But yeah, and I just for some reason have this goal in my mind where I want to get like the highest in like almost every one of my classes. And so far it seems like it could happen, but with the setbacks that's happening, it could drop down.
Yeah, so it's interesting. Evoli's saying like you only need a 90 for a 4.0. It is true. So at UCLA we have plus minus grading. So to get a full 4.0A, you need a 93. Because between a 90 and a 93 is technically an A minus, which is a 3.7, I think, Evoli. Is that right?
That's a lot.
Yeah, kind of sucks.
But since like my college is making it more challenging, they put it down to 90.
Okay, that's good.
But
fraction.
I mean, hey, but like so far, out of like I take 7 classes right now, only 4 of them are above 90. The other 3 just need a little work on.
Good. Well, you know you can always get help here, dude. If you need help with the classes getting up to like a 90, we got you. Right, when are you gonna when are you gonna go pick up the Nintendo Switch that you won? That's my question.
I mean, well, it already has been shipped to my aunt, as you already know.
Nice. Yeah.
The only issue now is how will I get that from there to here? That's the only issue now.
I know. Yeah. So for those that are watching, because I know we have a lot of people on YouTube right now, we have a whole nonprofit on our Discord, like a big community here, and we got like 1,700. What we do is we incentivize students to do well in their math and science classes by letting them earn points if they ask questions on the stream, if they show me they got good grades on their homework, for instance. So some students have done that, like here in the good grades channel. Ethan, right? Yeah, you're like, look, I got a 25 out of 25 on my thing. You know, you got points for that.
But that's only the beginning.
That's only the beginning. Also, if students go walk, like if they show me on their pedometer that they did a certain number of steps, I also give them points. We have tournaments, gaming things, and what we actually had this summer was we had like a little virtual summer camp that around like 30 students competed in. We even had like a talent show. SCP were the points, right? And then Ethan ended up winning the grand prize, which was a Nintendo Switch 2. So congrats, Ethan, to that. Yeah. Look, it's real. This is not a scam. I really do send out prizes to kids for doing things.
Yeah. And also about, yes, he has sent me. Well, technically sent me that.
I've legitimately sent prizes to people. But yeah. So if you're a student and you're looking for a little bit of motivation, or even if you maybe you know some students, like maybe you're an older, I don't know, adult, or you're a middle-aged person and you have a younger brother or like a kid that needs help with getting excited about math and science classes, tell them to go like join our Discord, and they can. You'd be surprised what kids will do for 1,000 V-bucks. So we incentivize them to do well in their life for 1,000 V-bucks, and they do it. It's cool. Anyways,
but hit that to go.
Yeah, what's up?
Like I was saying, how do I say it? All right, did you show everyone that video you told me you would show last week of what I did for my talent show? My first.
I'm gonna put that. I am gonna put that on LinkedIn in a couple days. I need to write another post for it. Yeah, but it is awesome. Yeah.
Where? LinkedIn?
LinkedIn's like a business website. Yeah, it's where like we show people like.
Yeah. That one. Okay, yeah, I know which one you're talking about. Well, wait, you're going to post that on LinkedIn?
Yeah, I'm gonna post on LinkedIn. I mean, do you not want me to post on LinkedIn? I think it's like pretty cool. I mean, you could be famous.
I mean, I really don't. I don't even access LinkedIn so much. But hey, like, let me know when it comes out. And
yeah, I will.
I wonder who I would be aware other than here.
It's a bunch of like educator people or like donors, philanthropists. Because yeah, that's the main way we fund any of this. I mean, a lot of it comes out of my own fucking pocket, but some of it is we get donations. Some of it we get like grants and things, and LinkedIn is a great place to get the attention of donors and philanthropists and companies. Like the Nintendo Switch 2 that Ethan won, I did not pay for because we had another company reach out and they said, "Hey, we will buy this Nintendo Switch 2. You just run the summer camp." And I'm like, "Cool, yeah, love that." So yeah, LinkedIn's a great. That's why I'm gonna post it on LinkedIn because it's good to show people that.
Yeah, but yes, what I did for my talent show was, of course, memorize 79 digits of pi.
You did memorize 79 digits of pi. It was super cool. It's a really cool video. It's very touching, and like I'm pretty sure it'll move the wallets of some like generous business people on that networking site called LinkedIn.
But I mean,
I'm hoping it does.
Like, I now know officially 100 digits of pi now.
That's super cool.
From my head.
Did you come up with that song, by the way? You did it with a song, right?
Oh yeah, but it was from like an original video, like back when I was young. But I just rephrased it into my own head and but without using any words and stuff. Really.
Oh, that's very cool. Nice.
And also one other thing, like,
what's up?
This was like before I actually knew I won the Nintendo Switch 2. But you should hear this.
Okay, let me hear.
Okay, when you listen to songs, what kind of main songs do you listen to?
I listen to a lot of like electronic music because I DJ and stuff, and like I kind of have to. It's kind of like my job. I have to figure out like what's the next song I have to play at an event or something.
Well, the thing is that so when I was little, I used to play a game called Dance Dance Revolution.
DDR. Yeah, DDR's sick.
I think it was like the 5th remix. I know it had the number 5 in it, but when I was little, I used to play that, got my feet moving. But there was this one song that caught my attention that...
Which one is it?
Wow, they really... It's something called Alphabet Aerobics.
Alphabet Aerobics. Okay, cool.
Now, just for a little backstory, this was created by Black Delicious. That's the name of the person. Black Delicious, yeah. So, what it is, the traditional ABC song, which I hate how they're trying to remix the whole thing.
A, B, C, D, E, F, C. What? EFC, sorry.
You done messed up,
EFG, not EFC.
Fucked up, dude. All right, yes.
The traditional ABC song, which I hate how they're trying to remix a new one. Like, that just doesn't even sound normal to me.
Yeah, it's okay.
But yes,
something new.
But yes, that song was based off of that, but made to be the complete opposite. Like, ABC is something easy for kids to learn. Alphabet Aerobics takes it to a whole new level of like alliterations, and you just as it and it just goes faster and faster as you listen to the song.
Mm-hmm.
The thing is that like I only learned like I learned it as a little kid. I didn't know so much words. I only knew like one or two, and then but right now I already knew how to sing the whole thing.
Oh, good, dude. That's cool.
You should check it out. It's
Send me the link for
really-
it. Send me
it's
the link for it. I'll do it. Let me pull up.
Okay, hold on.
Yeah, go find me the link.
Let me
Let me see. Let me see. Scarab, if you're still in the chat, let me just say how I did this one real quick, and then Evoli, we're gonna work on your question because thank you, you've been so patient. And then also, yeah, if you're also still watching, I have this question that I got submitted, so just hang around, I'll do them.
all right there. See,
Blackalicious. Oh, alphabet aerobics. Oh, okay. Oh, I can't play.
The thing goes pretty fast.
I can't listen to it on YouTube because they'll demonetize this channel if I play it while we're on here.
Oh, all right. It's alright.
I'll listen to it later.
I learned the whole thing. I listened to the whole thing without missing any words and knowing it off the top of my head.
Nice. It's cool to be able to memorize stuff. That's a good life skill to have.
Yep. I'm going to ask a question for tomorrow.
Okay, good.
Like,
yeah, ask a question for tomorrow.
But wait, it's the same thing with hexadecimal to decimal thing.
I learned some really cool tricks with hex on the last stream. One of the viewers showed me some really cool. I think it was Kent. I think Omega Kent showed me a really cool thing for hex. Yeah.
It's pretty good. But it was that same image I posted in like help screenshots. Could you still find that, or do you want me to find it for you?
Resubmit it. I have so many screenshots coming in. Just resubmit it. I'll do it. Okay. Let me help out Evoli with this question.
Sure.
Okay, is that cool? Okay, awesome. Oh no, where'd Evoli go? Evoli! Oh, she says I have to go. Fuck. Damn. Sorry, Evoli. I was literally right about to do your question. All good at Evoli. Was right about to do yours, but let me know when you get back. Okay. For Scarab, real quick, let me just show how this one happened. So, if you have something like this, and you need it to eventually look like this, you first have to flip it over the x-axis, and that's what we did to get to here. And then we had to translate it to the left, and then we had to translate it down, and then you have to do a horizontal compression and a vertical compression, and then that gets you the same thing. But nice. Okay, cool. Good job, Scarab. Thanks for... I see... I will get to chat at some point. But also, Evil, if you want to do yours like right now, we can do it. I'm so sorry. We've had a lot of requests today, which this makes me think I need to do this more often because there's obviously a high demand for it. Evoli is typing a lot right now. Evoli, what are you typing? And then let me see. I want to go through a lot of you guys talking about some cool stuff in my chat about. Okay, totally. I'll be on 30. Just holler and I'll switch over to yours. Okay. Let me see. What were you guys saying in the chat real quick? Abdullah says, God bless you for helping the students. Yes, awesome. Thank you. Appreciate that. AC's Wizard, can you give me some tips to keep the motivation to study? I love math and physics, but sometimes it can really be such a chore to study. Maybe it's the school environment. Yeah. Yeah. You know what I say is that if you want to get good at studying or any sort of like discipline or schedule, it helps to have discipline and schedule in another aspect of your life. So that can be something like practicing an instrument, reading books, going to the gym. I think life holistically, if you want discipline in one area, you have to kind of practice it in all the other areas. So yeah, if you say like, for instance, I'm on vacation, holiday, my schedule's whack, it's going to be hard to stick to any sort of studying schedule if every other schedule in your life is like not, set. There's no discipline there. So I tend to be more like holistic in like treating the issue. So yeah, maybe that would be a good thing. Yeah, and exactly. If you do well in classes and you don't even try, you get kind of screwed later because then you haven't built up the discipline to like try. So this happened to me for instance, in high school. I didn't have to study much for any of my calculus classes because I just got it instantly. It was easy. And even through college, I didn't have to put that much work in because I could pick it up pretty quickly. And then I got to grad school and I got hit like a fucking bag of bricks, dude, by graduate quantum mechanics because it just wasn't making sense to me. And I had kind of like coasted on my, natural intelligence up until that point, and I finally hit a wall, and it was pretty real. But that's when you really want to have some sort of study habits already built. And also for sure, shitty teachers will make you have a shitty time. So I agree with Peter when he says study with friends. 100% agree with that. That's what got me through a lot of physics classes that had bad teachers or I didn't understand. Having friends to kind of commiserate with will really help you push through. Also, if you surround yourself with quote-unquote smart, intelligent, driven people, you will also be smart, intelligent, and driven. So pick your friends, with that kind of in mind. Or at least pick who you hang out with to be the type of person that you would want to be. So for me, I had like different friend groups, and like my physics friend group, I would spend a considerable amount of time with because I wanted to do well in physics. I had my other friends, like we play beer pong and like whatever, get fucked up, have fun. But if I spent more time with them, then I wouldn't be doing as well in physics. So you have to kind of shift your priorities a little bit. And yes, most teachers don't give a fuck about teaching, at least at the university level, because they're hired not to teach. They're hired there to do research. And the teaching is to them almost an annoying consequence that they have to deal with. So I'm not saying all professors, but a lot of professors at big universities, especially research universities, do not like teaching. And so they don't really give a fuck. They don't put much effort into it. And unfortunately, it discourages people like yourself from like really being motivated to do more. But kind of see the light at the end of the tunnel, which is hopefully physics research is what excites you. And that's why you're taking physics or you're in whatever program you're in. So try to get more involved with research as an undergrad. And I think that will help you see the coursework that fucking sucks as being just a necessary evil for you to get to like doing the actual fun stuff. Yes, Abdullah's right too. Tidy your room. Yeah, my mental health is 100% directly correlated with how many dishes are in my sink. If my kitchen's a mess, my mind is a mess and I can't do shit. So I 100% agree with that, Abdullah. Yeah. So build the discipline. Okay. I said, okay, this question, whose question was this? Let me see. This got submitted almost an hour ago from, well, I don't know who this is. You can totally ask a question about UCLA. What's up? Okay, so I have this one. I also have this one. I'm tempted to do yours, Gordon Freeman, because you're here. If this was your question and you submitted it to me, please speak now or forever hold your peace.
Nice.
Otherwise, I'll get to this one later. But Gordon Freeman, I will do yours. This is yours, right, Gordon? Yeah. Oh, Max. Max, is this one yours, Max? Sorry. I'm gonna say Max, and I'm gonna say this is Gordon. Okay, let me do Max's then. I think. Yeah. I teach undergraduate physics at UCLA, or I did. I'm not teaching this quarter because UCLA is getting fucked with funding.
That's dope.
Not dope. But I did teach the last 2 quarters. I might teach later. I dislike f of x questions so much. They're not too bad. Here's a way to always think about f of x. Let's say it says, for instance, here, right? F of x is equal to, what is this? Negative 3/2. And then this is like a big X. And then plus 11. Nice. Yeah, it's tough, man. If you want to be a professor, prepare to like have a life of suffering and pain for a while. Or at least a life of not making a lot of money for like 10, 15 years. But as long as you're not there for the money, then you're great. You'll make it. My mechanics teacher said in his first lecture, I'm not here to make physics fun, dude. That's no, that's awful, dude. That's terrible. What? That's awful. That's a terrible teacher. Don't do that. Why would someone do that? That's so bad. Okay. Let me explain this real quick, and then Taco Cat, I will answer your question because that's a cool one. So, all right. So Max, f of x is equal to negative 3/2 x plus 11. What this means is that whatever is here needs to be the same thing here. If this, for instance, had like an x squared, then whatever's here has to also go here and also has to go here. But this doesn't have an x squared. So when they say, for instance, f of negative 8c plus 2. Okay, we're going to move this around. Let me give her a little bit of space here, right? So now instead of it being f of x, it's negative 8c plus 2. And so now this is going to get replaced also with, and you should always put parentheses around this, Max. This is also going to be negative 8c plus 2. Okay? Oh, you love having a teacher? Oh, I appreciate that. Yeah, I mean, I think a lot of people appreciated me as a teacher. I have a lot of great reviews on like UCLA and stuff. I love this. I love when I get like student reviews. It's pretty awesome. Makes me feel good. But yeah. Okay. Nice. I'm glad, AC. You can still teach too. I say, like, I'm not the only person doing this. I don't have a monopoly on this. You know, if you want to still kind of get that same satisfaction of doing things, you can go volunteer for whatever they have tutoring at different places. You can go to inner city places, and I choose to do this, YouTube and stuff, because it's the way I can reach the most amount of people. I do like tutorial videos and stuff that, you know, help people while I sleep, which is nice. I appreciate you. Aw, Sib, thank you. I appreciate you too. Okay, so Max, once we've replaced x here with this, that means this x needs to also be replaced with this, but always put parentheses around it. Then the next step, Max, is to just simplify this, okay? So that means we're going to distribute this into both these things. So this is going to be negative 3/2 times negative 8c, and it's going to be plus negative 3/2 times 2, and then we still have the plus 11 just hanging out, right? Okay. So then you got to simplify. And so this is going to simplify. I always like to do this. I'm going to cancel this 8, make this a 4, and take this and be a 1. If that's confusing, you can still just multiply you can call this like over 1. Multiply the top, multiply the bottom. So that would be 24c over 2. Plus, this is going to be negative 6 over 2. And then plus 11. This is going to simplify to 12c. This is going to simplify to minus 3 plus 11. And so you're going to get 12c plus 8 is equal to f of negative 8c plus 2. So that should be it, Max. Let me know if that made sense. Tell me if it didn't make sense. I'd be happy to help you with it. If there are any steps that don't make any sense. Stop throwing new undergrads under the bus. Yeah, the other f of x questions bring me middle school trauma. Oh no. That makes sense? Okay, awesome. Great, Max. Thanks for waiting, dude. We're having a busy day today. But again, if you're just finding us here from YouTube and maybe you got to go to bed, you got to go to eat some dinner, or you can't hang around for too long, we do have a schedule that's on this website here. If you go here to like streaming schedule, so that website, the actual discord.com/submit, you go to streaming schedule here, and this has a Google Calendar that updates live of all the times I go live, as well as all the times my other friends who stream math and science go live. So Zach was on earlier today doing like a software development stream. He's a really cool math streamer. He has a math PhD. So for high-level math questions, I say always go talk to Zach, and he's streaming again, I guess, on Friday. But that's the schedule so far. What's up, Shanktrix? Yeah. I love this, but not YouTube short streaming. Above this is an AI slop 24-hour stream. This old man gambling. Okay. Well, so Sebastian, we stream on all the platforms. So, like we said, from where was it? From this thing, you can watch us on Twitch. Twitch is a better format because it's horizontal, and you can see my full whiteboard and stuff. So please watch on Twitch if you want like a better experience. We do stream it on Discord as well. That's if you want to talk to me live. If you want to like hop on the stage and talk with me like on a voice channel on the stream, you can do that on Discord. And then we also do it on YouTube, and then we also do it on TikTok. The reason why I do it on YouTube Shorts and TikTok is because the algorithm pumps so many more viewers to it. It's nuts. And again, for anybody who's streaming, if you want like a little tip, right? So I currently have, 10 viewers on Twitch, which is cool. I mean, it's not bad. I mean, the format's great and stuff. And I do have a really awesome community on Twitch, and I love those people. They're great. But if you want to look at, for instance, the metrics I get with YouTube Shorts, just because everybody's on their phone, everyone is doom scrolling, we're already at 4,700 views. And 52 people are watching. So this is why I feel like if you're trying to reach the most amount of people and have the biggest impact, you need to cast a wide net and just fucking broadcast it everywhere. And you never know what'll hit. YouTube Shorts has been really, really good to me recently. So I'm making sure that I stream on YouTube Shorts. Also, they're kind of the only one that really gives you decent income once you reach like the monetization level. Yeah. Am I late? No, you're still here. Okay, sorry, Taco Cat. One sec, your question, because I do want to answer that. You found me doom scrolling sick. Exactly, and that's why. That's why we stream on YouTube Shorts. Is so that while you're doom scrolling, because you're not the only person doom scrolling, you might find something like educational that you could be involved with. I can definitely help you with a problem. If you want to send me a screenshot, I'll do it. I'm going to do this question next from Gordon Freeman. It's a physics question. But let me answer Taco Cat. Sorry, Taco Cat's he's a mod in our Discord. So Taco Cat's been around a while. OG. Yeah, you found me doom scrolling. Yeah, exactly. So that's why you know. I always say these companies spend so much money trying to find ways to keep you attached to your phone and keep clicking and keep scrolling. So I just piggyback on that and say, okay, cool. Well, if you're going to keep doing that shit, you might as well like learn something. We will do projectiles. Bree said, I also found you while doom scrolling. Yay, cool. Doom scrolling gang. Maybe I'll make a tag, doom scrolling gang. Yeah. Yeah, we will do the projectiles. Let me answer Taco Cats. So Taco Cat says, I know you went to UCLA and got a degree. So I was wondering, did that degree help you get a part-time job at UCLA? Or is it your work experience with tutoring and the Discord Twitch that helped that I do? Yeah, of course. Yeah. So, yeah, I did get my PhD at UCLA. And then I went off for 3 years to do this work. I do like nonprofit work, teaching math and science to like middle school, high school kids. Again, YouTube, Twitch, TikTok, all the fucking stuff. I also do consulting for a textbook company that is trying to take down the monopoly, which is Pearson and McGraw-Hill, all these fucking awful textbook companies. That's really what got me my job, Taco Cat, is that the textbook company I was consulting for is also founded by a UCLA professor. And so when they needed someone to come in and teach physics, they were like, well, we already know this guy's good. He already works with a bunch of like college level textbook stuff. you definitely need a degree. In order to teach physics at UCLA, you need a PhD. So I had to get a PhD at some point. And did it help that it also came from UCLA? Probably, because they know who I am. But yeah, I don't think I got the job specifically just because I have a PhD. There are plenty of PhDs that don't know how to fucking teach. Exhibit my chat, right? The people you guys are talking about, some professors that are just awful. Yeah. I love when I get some science and math facts. Yeah, it's dope. Nice. Yes. I despise Pearson. Yeah, Pearson sucks. Yeah, that mastering physics shit needs to die. It's so bad. Yeah. I hate when people bring me mastering physics questions to do, it like hurts my soul. Cuz it's just awful. Yeah, okay. The textbook company is Kudu, yeah. So you get the problem now. Okay, Gordon. Do you want me to still go through it? Because it'll probably teach someone. It'll teach other people stuff. Or if you have something that's harder that you don't get right away, I'm totally fine to do that as well. Yes. Yeah. Yes, send it in the Discord, Sebastian. I'll do it. Okay, we're going to do it anyways. Okay, we're going to do this one. And then, Sebastian... let me see if I see yours. Did you put it in the... Oh, yes. Yes, totally. I can do that one. That's cool. AP Physics 1. I love AP Physics 1. Yeah, Sebastian, I'll do yours right after this one. Let me do this one. Okay. A physics student is standing on the edge of a cliff. Don't jump. And it throws a stone vertically downwards with an initial speed of 10 meters per second. The instant before the stone hits the ground below, it is traveling at a speed of 30 meters per second. If the student were to throw the stone horizontally from the cliff instead, with the same initial speed of 10 meters per second, approximately how fast would the stone be traveling just before it hits the ground? Assume air resistance is negligible. This is actually this is like a mind fuck of a question. Yeah, this is pretty cool actually. Okay. It has to do with components of velocity, right? Okay. So let's think about the person throwing it down. Okay. So the person who throws the ball straight down does so with what we're going to say is like, we're going to say Vy naught is equal to negative 10 meters per second. Okay. And then right before it hits the ground, okay, so we can say Vy final, or Vy1. 1 is usually like the next situation. Because sometimes you have like you have like 3-stage situations. Like it's here, then it's here, and then it's here. It's equal to negative 30 meters per second. Okay. So now that was student 1. Okay. Student 2 throws it horizontally. Okay. With a Vx, or with a Vx naught equal to 10 meters per second. Cool. Approximately how fast would the stone be traveling just before it hits the ground? Am I allowed to use conservation of energy, Gordon? The horizontal... Yeah. Yeah, so the horizontal component does stay the same. So even though when this thing falls, right, it's also going to have... I'll show it in 2 different ways. So it's also going to have a component of velocity in the x direction. You're in kinematics. Okay, so yeah, so no conservation of energy. That's fine. So Vx1 is also equal to 10 meters per second. But now there's also a component of Vy1, which we don't know. Okay, but here's the cool thing. So, I know from this that we know this for all objects. The amount of time that something spends in the air is only dependent on its y velocity, its initial y velocity. So from this, I can figure out how high the thing is. Okay, we can figure out the height of the cliff. I'm pretty sure we can here, right? So from this equation, which, all right, I'll just write it out. It's okay. So v1 squared is equal to v naught squared plus 2a delta x, right? You know that the final velocity here, right, is negative 30 squared. The initial velocity here was negative 10. The acceleration exactly, yeah. Yeah, here. Yeah, for this one, sorry. Yeah, Vy naught is equal to 0. Good. So then this is 2. And then they want like approximately. Okay, so if they say approximately, I'm just going to use negative 10 for the acceleration. What's up, Mies? So this is negative 10 delta x. Do we agree with this so far, Mr. Freeman? Mr. Freeman. Oh, and I should have done this in the right color. Sorry. Ugh. Yeah, sorry. Let me fix this. Sorry. V1 squared equals V naught squared plus 2a delta y. Good. Okay, cool. All right. So I'm just gonna because I want the colors to be the same. Negative. No, wrong. Sorry. Negative 30 squared is equal to negative 10 squared plus 2 times negative 10 times delta y. So that's going to be 300 is equal to 100 minus 20 delta y. Subtract 100, subtract 100. 200 is equal to negative 20 delta y. Cool. So this tells me right away that delta y is equal to 10 meters. Cool. I have played Half-Life. Yeah, dude. Yeah. I remember when Half-Life 2 came out. I think I was in high school. Okay, so this is 10 meters. All right, cool. So now for this one, all right, we can do the same thing. So v1 squared, I don't know what it is. V naught squared I know is 0. And then plus 2 times the acceleration, negative 10, and now delta y is also negative 10. So that means v1 squared is equal to 200. 30 squared is 900. Oh, I fucked up. Fuck. Thank you. Thank you. I make mistakes too. Thank you. Awesome. Yeah, good. I'm just checking to make sure you guys are awake, right? That makes more sense. Okay, cool. 40 meters. Cool. Whatever, 4. We are humans after all. Yes. No, of course. And I think that's one of the key things. All right, wait, sorry. This is all wrong now. Sorry, this is 800. Okay, cool. So, okay, this is v1 y squared. I'm going to leave this squared. I'm going to show you why. It's kind of cool. First of all, let's make sure I did that right. Yeah? I want to make sure I didn't do anything wrong. Cool. 40, yeah. 402. Good. Okay, cool. Okay, so now the final velocity here, that's going to be, so v1 squared total is going to be equal to v1x squared plus v1y squared. So that's going to be equal to 10 squared plus 800. So v1 squared is equal to 900. Cool. So v1 is equal to 30. Same velocity, yeah?
My man.
I think that's pretty cool. Is the correct answer C? Is that right? I'll show you the easier way to do this with like conservation of energy. You got it, Akshay? Cool. It is C. Nice. Okay, cool. We got that right. Yeah. Awesome. Okay, I'm going to show the even easier way to do this one without having to do kinematics, although it is cool that kinematics is self-consistent. And then, Sebastian, I will do yours. But yeah, the trick to get good at physics is what I call pattern recognition. And because there's only so many different types of problems that can be asked. And so if you can recognize like what box the question like fits into, then you can instantly go ahead and just solve it. And the way to recognize what the different boxes are is to do a bunch of different questions. Then you start knowing like, oh, this is a 1D kinematics question. When I saw this right away, I'm like, this is a conservation of energy question. But then I remembered that you're not allowed to use conservation of energy because you're only doing kinematics. But doing problems and then understanding why they are, that's the best way to learn physics. Millwright says, is there a long question? I would like to know before I send my question. It was the only one I got wrong. No, there's not a very long one. Yeah, I'm going to explain this one real quick. I have one more to explain, and then I can do yours. That's the next in the list. Yeah. Let me show real quick. The other way to do this is called conservation of energy. Okay. Which, again, let's say like student A. Yeah, submit it using the website, and I'll probably get to it in the next 10 minutes, 15 minutes. Student A, student B. So you have to look at what's called like potential energy due to gravity and kinetic energy, which is due to movement. So student A, when they throw it downwards, this thing starts at a height h, so it has potential energy equal to mgh, and its kinetic energy equal to 1/2 m times the velocity squared. But the velocity it's being thrown at, right, is 10 squared, right? And then, actually, this is even cooler. We don't even need to do the starting. Let's just do it at the end. So at the end. So at the end, okay, this thing has potential energy equal to 0. It has kinetic energy equal to 1/2 m times 30 squared. Okay. For student B, when the thing hits the ground, like over here, this is also equal to 0. And then the kinetic energy is also equal to 1/2 m v squared. Now, both of these things at the beginning started with the same amount of energy, because student A at the start had mu g equal to mgh, and it had ke equal to 1/2 m times 10 squared. This velocity doesn't care about the direction, so this was down. Here, mu g was equal to mgh, but here kinetic energy was equal to 1/2 m times 10 squared, but this was to the left. Yeah, conservation energy is so cheating, right? So they both have the same starting energy. So they must both have the same ending energy if there's no non-conservative forces like, yeah, fucking drag or whatever. So that means this has to equal this, which means that V has to equal 30. And you're done. So I know you haven't learned conservation of energy yet, but when you do, that's why this is like a trivial question to do. It takes like 2 seconds versus having to nice. Let's see. Nazir, did you just submit a question? I don't know. It submitted this one for some reason. I already got this question submitted. Maybe try putting the screenshot in again, or maybe it's fucking up. I hope it's not. Yeah, no, that's the same image. Try it again. It might work. Oh, one sec. I gotta reload this. We've exceeded the amount of time. Okay, and I do have a student I have to teach in 17 minutes. Okay, good thing I remembered that. I was like, oopsies. Okay, 17 minutes. All right. Cool. Let me see if Sebastian's around. Cool. All right, Sebastian, I'm gonna do yours right now. Okay, let's see. No, not that. No. There we go. Okay. A world-class runner can complete a 100-meter dash in about 10 seconds. A team of sports scientists are studying the motion. Cool. the distance data has an error range of 0.3 meters. So this is... Okay, now I see yours, Dark Jazz. Is this yours? Right here, this one? PVC, that's kind of fun. We're doing a PVC question? I'll do that next, yeah. Is this statistics? I don't think it's statistics. Okay, so this is... Yeah, but you're right, because I do see uncertainty, right? Which starts to make me think like it's statistics. Okay, this is plus or minus 0.3. This is plus or minus... Okay, whatever. At what time does the runner approximately quit accelerating and begin to move with constant speed? Okay, so constant speed, right, is when velocity... the change in velocity is 0. So, constant speed is when the change in velocity is equal to 0. And let's remember how we define velocity. Oh, you're good, Nazir. So, if I wanted to, for instance, find the velocity between this and this, right? It's distance divided by time. That's equal to 1.5. The velocity here, right, is this distance minus this distance divided by time. So that's 6.1 minus 1.5. So here, this is like velocity that we're approximating. Sorry, that's 4.6. Okay. And then this one minus this one divided by 1 second is going to be 7.6. This is going to be 10.7. This is going to be 12.5. And then this is going to be 12.6. Okay, look. You see how the velocity hasn't changed? Right? This is what we want. Because then from here, this is 12.7. And then here, this is 12.6. Okay. So I would say... yeah, are you talking about like log rules? Log rules are just how logarithmic functions work. Logarithms are really fun. Yeah, I like logs. I'll show you a video I've done on logs. Okay, so they quit accelerating when the velocity stops changing. And I believe that happens here, right? So, I believe it happens between 4 and 5 seconds. So I would say at 4.5 seconds. Or, I would really say 5 seconds. I would say, let's say at 5 seconds. Because the velocity before 5 seconds and after 5 seconds is about the same. If that makes sense. Yeah? Yeah, well, logarithms are good for, like, exponentials is how they work, yeah. Okay, why use the velocity symbol when it's equal to delta x over delta t and speed equals delta d over delta t? Should you use s as the symbol? So what I'm doing is I'm preparing you for physics. Wait, this is physics, okay. Speed doesn't have a direction, which is tricky. You want like speed can't be negative. Speed is only positive. It's much better to use velocity, because that also tells you like what direction something's moving. So I agree that S is sometimes used as like position, but I would use V. Because I see. Are you saying like because I have I see why you're saying because I'm doing delta D over delta T? Because I mean velocity technically is like the change in distance. It's also the change in position. You can say position if you want. So like x2 minus x1. That's okay as well. And then just know that this distance is like the position away from where it started, I guess. Oh, okay, cool. If you need help with log rules, here, I'm gonna literally give you the video I have for it. So, here, this video here, Maiden, I made, I made a cute little video here that should like explain just the easy log rules that you need to know and like why they work. So I just sent you the link for it. Yes, exactly. Distance is a scalar quantity when displacement is a vector quantity. Correct. Yeah. Yeah, so when your teacher just starts telling you things but doesn't like explain like what they mean, I can see why that's confusing. Cause right, okay, so here, let me show you. So let's say this is your start. If I move, let's say to here, this would be a distance, and let's say this is 5 meters, okay? Yes, the distance you travel would be equal to 5. But another thing I would say is I would say that the position, or I'd say the displacement, so displacement from 0 is equal to 5. That would be like x. The reason why I want you to get comfortable with saying like position and velocity is because if something moves to the left, okay, technically the distance is still 5, even though these are two completely different situations. But the position or displacement is x is equal to -5. Yeah. So when we talk about in this question, the distance, I like to think of it as, well, really this is x equals 0, and then we're measuring distance away from it going this way, okay? And so velocity, like for instance, this is like an x, this is an x, like this is x2, this is x1. So subtracting these two will get you a positive number, which points to the right, which is important because it tells you that the velocity is positive. The reason why that's important is because when we talk about acceleration, now it really matters whether the velocity is positive and getting more positive or negative and getting more negative. Like those are two different situations. So just get comfortable with this. Don't use position. Don't use speed and distance. They'll just confuse you if you do it more. So use position and velocity. Okay. Average speed. Okay. So average speed. This is equal to like yes. Total distance divided by time. Okay. Average velocity here is equal to total displacement over time. Okay. And there's a difference between these two, and I'll show later. So for average speed, he goes a total distance of 100 meters. And he does it in 10 seconds. So that's 10 meters per second. What's up, Preeti? But why I want to talk about this is, let's say something, for instance, goes from here to here in 1 second. And then comes back in 1 second. Okay? So let's say it does like let's say someone does a round trip. Okay? And let's say this was 1 second, this was 1 second, okay? The distance they would have traveled there would have been 5 and then 5. So that would have been 10 meters. So average speed, which is distance over time, would have been 10 meters over 2 seconds, which would have been 5 meters per second, okay? However, if we wanted to look at the displacement only cares about the difference from where you start and where you finish. If you start here, you come here and you come back, your displacement is equal to 0 because the distance from where you start from where you finish they're the same place. So net displacement is 0. Good. So average velocity is equal to 0. And the reason for that is that the velocity when you were going this way was positive 5 meters per second. And then the velocity on the return trip was negative 5 meters per second. So the average velocity, because this is the same distance and the same time, is 0. That's where that comes from. So in this case, because they're always moving to the right, average speed equals average velocity, because the distance they travel is the same thing as the difference between their starting and ending positions. Okay. Constant velocity after acceleration quits. Well, yeah, that's probably around, I would say, 12.6 meters per second, right? Because that's what this thing looks like it averages out. Without discussing specific numbers, explain why your answer to part C is greater than your answer to part B. Okay, good. So their velocity here is slow, right? Here they are slow. They're only traveling at 1 meter, 4 meters, 7 meters per second. And then here, they're fast. So even though their instantaneous velocity here, so that means the velocity at these time points is high, because they were slower in the beginning, the average of it ends up being less than what it is during the fast part. Does that make sense? So you can say like instantaneous velocity at beginning is slow. So average is slower than like the instantaneous velocity at the fast part. Cool. Okay. Let me help out. I love all these questions. What? This one's nuts. Yeah. What's this? What? I know this question, dude. This one's a mess. Yeah. Thank you everyone in my chat for like who's helping people. Here, let me do this one real quick. And then I do have to go. I have to teach another student. Yeah, logarithms show up a ton in chemistry, especially if you ever do like kinetics and like rate laws. That's all like, you know, first order, second order stuff. Okay, here we go. PVC pipe sections. You need to connect two PVC pipes that have inside diameters of 3.25 inches and 0.4 inches thick. What diameters in inches must the adapter have to fit tightly over the pipes? Oh, that's cool. Okay. I think this is a pretty simple question, no? Cylindrical shells. Yes, we love shells. What is young Cardi asking me about death? Dude, what? Okay. So, this is kind of cool, right? So, if we know, for instance, that this right here is 0.4 and this right here is 0.4, then the total inside diameter of the thing that connects them needs to be 3.25 plus 0.4. Sorry, plus 0.4 plus 0.4, which is the same thing as 3.25 plus 0.8, which is equal to 4.05. So that's why this one is just this. It's not as tricky as I made it seem. Yeah, they're just trying to see, like, if you have two pipes, like, how do you have the things go over the pipe? Okay. Cool. Yeah, Nazir, it's not that bad, right? I know, it looks harder than it's supposed to be. Not too bad. Cool. Yeah, you're welcome. Okay. Oh, Nick. Oh, you sent me more things? Fuck. I really have to go, Nick. I have to teach another student now. Yeah, we have been going for 3 hours. Okay, let me wrap up the stream. Okay, cool. Thank you, everyone, for coming to Actual Education Office Hours. Appreciate all the questions. Fun stuff. You guys are great. No, it has to end. I know. Sorry. Time to say goodbye. I have to go teach students for money because I have to pay my rent. And I have a student in 1 minute that I have to go teach. So, thank you for finding us. Thank you for visiting. Make sure, please, like, subscribe, turn on notifications, all that fun shit, because that tells the algorithm that you enjoyed our channel. And so when I go to stream again, they'll pump us higher up on the algorithm preference. So people doom scrolling through like feet pics and gambling and like whatever get shown this instead. Yes, we can do yours tomorrow first. Yeah, that's totally cool. Yes, awesome. Yeah, no. So yes, if you found us, awesome. Please like, subscribe, all that fun stuff. If you want to like join our community, it's we have a lot of. I got like 1,600 people in a Discord. If Discord is your jam, you can just go to the website down below and then just go to join our Discord. If you want to like keep the conversation, like keep in touch with people, we have a pretty fun community of students. And if you want to help other students, like I always have students asking questions. Like I appreciate you guys in the chat helping out. What was it? Marion made us about with her logarithmic questions. But okay, I need to go. If you're watching us on Twitch, I'm gonna go raid somebody. Raid means that like we just send all the viewers from our stream to someone else's stream, because I'm not the only person that does this. We have a lot of other people doing math and science stuff on the internets, such as Moohoodles or physics and depression. Yeah, let's go say hi to physics and depression. Or he says BRB. Is he gonna be back? This is a cool guy. He does like physics questions. Fuck it. Wait. Sorry, go back. Can I link my Discord? Yeah, of course. Yeah, here, I'll put it in the chat real quick for you guys. And then I gotta go. Fuck, where is it? Yeah. There you go. That'll take you to our Discord. It's alright. It's on the website. Okay, go say hi to Physics and Depression. He's a really fun guy. He does like physics self-study stuff on Twitch. He's BRB. He'll be right back. So go. He's going to the bathroom. So go say hi to him. Enjoy the start of your week. Stay awesome. Thank you again for coming by. And we will see you tomorrow, 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Peace.